For the last section, we have quadratic, or not quadratic, but rational inequalities. Right? I'm changing my notes so you can see my new list that I've created to solve them. Think of it as a fraction that's greater than or equal to, whatever, another fraction maybe. The only thing is we're going to have variables on the bottom, right? So the first thing is you always want to find when our inequalities are undefined. To find if something is undefined, you set it equal to 0 and solve. Okay? Number 2 is you're going to change your inequality to an equal sign, okay? You can make it just equals. Okay? Get rid of these symbols. Make them equals. Then you're going to solve that equation. Now, to do that, usually if there's a fraction in it, we're going to clear denominators by multiplying through by LCD. After that, you're going to have solutions, okay? You're going to make a number line with the solutions and the undefined numbers on it. So whatever you got as your answer to the equation, you're going to put on it, and you're also going to put your undefineds on it. I also circle my undefineds because later when we pick our regions, you never include anything undefined. It blows up the world. You then, after have is a bunch of, well, sections, okay? You're going to test those sections. Okay, to do that, you take a number in those sections, never pick the numbers on the line, the endpoints, the intervals, and plug them in. You're going to see if they're true. If it's true, I mark it true. If it's false, I mark it false. Okay? And our final thing is to list the regions where the solution is true. Alright? So you're going to use your brackets and parentheses and put them all together. Let's go through at least 2 of them to see how we do. Alright? So, this was the original procedure we had. And let's see if we can figure out this one right here. Okay? So, first things first. I'm going to see if this is undefined. Is this undefined? Bottom ever equal to 0? No. Right? Step 2, I'm going to change this to an equality. Step 3, find the LCD. No, 7 and 5 is 35. To solve it, step 4, well, kind of step 3, is solve it. After you find the LCD, multiply through by it. 35 and 35. Do your canceling. The denominator should be gone. Should have 5 times 2 minus d equals 2d minus 2 times 7. Okay. And now all I gotta do is solve. 10 minus 5d equals 7d minus 14. Get d alone. I'm gonna add 5d. 10 equals 12d minus 14. Add 14. You get 24 equals 12d. D equals 2 by dividing by 12. Okay? So we have that. Now we make a number line. Okay? It's a pretty easy number line because the only number on it is 2. Alright? So now we need to test numbers greater than 2 and less than 2. Always pick numbers that make it easier. Okay? So sometimes you're going to have to do some scratch work. Alright? So you're going to see me try that once in a while. Okay? So if I pick a number greater than 2, let me think. What could I pick? How about, I'm going to pick, let's pick 9. There's a reason for that. Okay? Let's try 9. 2 minus 9 over 7 is negative 1. That's why I picked it. And then 9 minus 2 over 5, well, that's 9 minus 2 is 7 over 5. Oh, is a negative greater than a positive? That's not true. So I'm going to write that as false. Right? Now pick a number less than 2 over here. So I picked 5. I picked 9 over here. That didn't work. I'm going to pick 0. So if I pick 0, that's an even easier number to pick. That's 2 minus 0 over 7. That's 2 sevenths. Is that greater than negative 2 over 5? And that is true. So all I got to do is list my solution. Well, it is this one over here. Okay, it's this side. Well, that's from negative infinity to 2. Alright? So, I go back to my inequality, see if it's less than or greater than. Alrighty? I go, it's from negative infinity to 2. Never includes infinity. And because there's no bar, you can't include 2. Now, if this was undefined, it would be circled. Even if there was a bar, you still couldn't include 2. As you can see, our final answer is x, or d in this case, is going to equal this interval. Now, let's take a look at the next one. I'm going to clear this up. Well, first things first, when is this undefined? Okay? Looking at my list of things. When is this undefined? Oh, set the bottom equal to 0. When does this equal 0? Oh, x plus 1 equals 0. X is minus 1. This is undefined. That's going to automatically go on our sign chart. Or our true-false chart, as I'm calling it. Right. Step 2. Change it to equal sign. 2 over x. 2 minus x over x plus 1 equals 3 minus 9 over x plus 1. The LCD of all these is just x plus 1. So I'm going to multiply all of them by our LCD, which is x plus 1. So x plus 1, x plus 1, x plus 1, and x plus 1. Alright, well, that doesn't cancel, so I got 2 times x plus 1. Cancel, cancel. Minus x equals 3 times x plus 1. And those cancel to be minus 9. Okay. Now all I gotta do is solve this. 2x plus 2 minus x equals 3x plus 3 minus 9. Combine like terms over here, that's x plus 2 equals 3x minus 6. I'm going to subtract x. 2 equals 2x minus 6, and add 6, which is 8. So 2x equals 8. Divide by 2. X equals 4. Now, I have this as a solution and the other one. Right? So our sign chart is going to go like this, or our true-false chart. -1 is on there, and I circle it because I know I can't be it. And then 4. I now need to test points to see how this works. Right? Again, the points you choose is going to make it easier or harder on yourself. Okay? So, pick a number greater than 4. A lot of people keep telling me 10. 2 minus 10 over 11 is greater than 3 minus 9 over 10. Well, this is 2 minus 10 over 11 is a little more than 1. This is 3 minus, just about 1, that's 2. So a little more than 1, is that greater than 2? And the answer is no. Okay. So 10 didn't work. Let's try my favorite number in between -1 and 4, 0. That's 2 minus 0. 0 over 0, 0 over 1 is 0. Is that greater than 3 minus 9 over 1, which is 9? Is 2 greater than -6? That's a true statement, yes. This is true. This one's false. Right. The last one, okay, let's try a number less than -1. -2 works. You're going to see why, because, well, it's -2 plus 1. Makes it easier. 2 minus -2 over -2 minus 1, which is -1. So 2 minus 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 is 2 minus, a lot of minuses, hold on, minus and minus is a plus, and that's a minus. This is actually 0. Is that greater than 3 minus 9 over -2 plus 1? It's -1, which makes it false. Is that a true statement? That is false. My answer is going to be then this region in between that, from -1 to 4. -1 to 4, automatically circled, it's a parenthesis, 4. Is it a bracket or a parenthesis? Well, if it's no bar underneath, it's got to be a parenthesis. So x has got to equal, in this case, between -1 and 4. The last one we have that I'm going to do is this problem right here. This one's actually a lot more complicated than it looks. Okay? So, first step is, when is this undefined? Well, x minus 2 equals 0 at x equals 2 and -1. That's my undefined. At the -1 from this one, -1 plus 1 is 0. Okay. Step 2, change this to an equal sign. And then find the LCD and multiply through. In this case, it's pretty easy. It's x minus 2, x plus 1. So x minus 2, x plus 1. X minus 2, x plus 1. Cancel out terms. So I have 2x times x plus 1 equals 3x times x minus 2. All I want to do now is distribute. 2x squared plus 2x equals 3x squared minus 6x. Solve a quadratic now. We have to get everything to one side. Subtract 2x squared, and I'm going to subtract 2x. So subtract 2x squared minus 2x. 0 equals x squared minus 8x. Factor out an x, because that's a common term. We factor to solve these. X and x minus 8. X equals 0, and x equals 8. So we have 4 solutions on this chart. for once. We have 0 and 8, but we also have our undefined, which is 2 and negative 1. And we also circled those because we can never equal those. We're going to try points now. Right? Trying points is actually a tough thing to do in this problem. Right? Let's try 10 to start. So I'm going to copy you, and I'm going to paste it down here. And to do this problem, we've got to actually test in this. All right, now, testing points isn't going to be easy. If you pick 10, 10 is the first one people always seem to choose. That's 20 over 8. Is that less than or equal to, well, 30 over 11? Well, if you do this, this is 816. It's 2.5 actually. But if you do this, this is about 2.7. Right? Is 2.5 less than 2.7? It's true. So that's a good answer. All right, pick a number between 2 and 8. Now, I pick 3. 2 times 3 is 6 over 1. Is that less than 9 over 4? Well, 6 less than 2 and a quarter? And that's a false statement. So that's false. Not many numbers between 0 and 2 to pick. I'll pick 1 just because that's all I can really do. That's 2 over negative 1, which is less than 3 over 2. Is negative 2 less than 3 halves? Actually, it is. Negatives are always less than positives. So that's a true statement. The ugly one is right here. We have to pick negative a half. Well, negative a half times 2 is negative 1 over a half. Negative a half minus 2 is negative 2.5. Well, negative a half times 3 is negative 3 halves. And then negative a half plus 1 is 0.5. Well, here's a nice thing. You can actually do this without figuring out the numbers. So all I need to know if it's true or false. You know, negative divided negative is a positive. Is that less than a negative? That's a false statement. So that's false. Okay. And then the last one, if you try a number greater than or less than negative 1, try negative 2. That's negative 4 over negative 4. Is that less than negative 2 times 2 is negative 6 over negative 1. That's 4 is less than 6, and that's true. So now we need to take the solutions where they're all the same, okay? How to do it is actually not too bad. All I need is to take regions. Well, we need the true, true, and true. Alright, so this region here is from negative infinity to negative 1. Cannot include that, negative 1, because we circled it. Now for the real question. The next one is from 0 to 2. Can't include 2 because it's circled because it's undefined. However, because this is an equal to, we can actually put 0. So we use a bracket. The final one, can we be 8? Yes, we can. It's a bracket and then infinity. Okay? So we have our final solution is this nasty looking thing, okay? But it is correct, okay? So to recap, find when it's undefined, change the inequality to an equals, solve, usually you got to do an LCD and multiply through, put the solutions down and the undefineds down, circle undefineds, make sign chart and test points, and list all regions that it's true. Okay? Keep working hard. Good luck. Talk to you later.